Could quantum physics unlock teleportation? The answer is yes. Recently, physicists manipulated and broke the speed of light for the first time in history, opening doors to the possibility of teleportation into another dimension. If there is one thing that science fiction films and comic books have taught us, it is that humans are limitless and will one day be able to open a doorway to another dimension. What if I told you that day is closer than ever? The scientific community has just made the most monumental discovery of this century. Will we finally get to find out if we are the only things in the universe? What scientific advancements have been made that would allow for intergalactic teleportation? How and where will these portals take us? Come with us as we investigate the scientific breakthrough that allows us to access a gateway to another universe. So, without any further delay, let's jump right into the video. Quantum teleportation is possible. The complexities of space have long captivated scientists and science fiction fans alike. The search for answers seems endless, as do the possibilities for discovery that lie deep beneath the uncharted reaches of space beyond our atmosphere. Researchers in the fields of astronomy and physics have been plugging away at their studies in an effort to finally solve these puzzles. An important development appears to have been made in quantum physics recently. Just last month, the 2022 Nobel Prize in Physics was awarded to 3 scientists for experiments with entangled photons, according to the Royal Swedish Academy of Sciences, which selects the winners. The research done by the winners proved that teleportation is possible, at least between photons. All 3 physicists, Alain Aspect, John Clauser, and Anton Zeilinger, made their discoveries independently over the course of several decades. Their work proved the existence of quantum entanglement and revealed how this mysterious quality might serve as a conduit for the teleportation of quantum information from one photon to another. In the quantum world, teleportation includes the transportation of information rather than the transportation of substance. The process of quantum teleportation involves 2 distant, entangled particles in which the state of a third particle is instantly teleported to the 2 entangled particles. According to the theory of quantum entanglement, 2 particles vibrating in unison are as intimately connected as a mother and her unborn child are connected by the umbilical cord. The particles continue to resonate in unison even after they have been physically separated. This facilitates the tiny flow of information between the 2 particles. Despite the fact that their discoveries have not yet led to the widespread use of Star Trek-style transporters at airports and train stations, they have found their way into promising areas like quantum computing, quantum networks, and quantum encryption. Now, before we delve deeper into this discussion, it is important we take a look at the recent experiments and work done on the subject of teleportation. Teleportation, recent experiments. In theory, teleportation would allow for the transmission of material or energetic particles from one location to another without the need to move the particles across the intervening empty space. It's been a staple of science fiction and other forms of popular culture for a long time. In science fiction, teleportation experiments frequently go awry, leading to the creation of grotesque hybrids like inside-out baboons, gene-spliced monsters, and dematerialized madmen, among other things. Despite this, the tests have not produced any abominations thus far and have shown a lot of promise. In 1998, scientists from Caltech and 2 European organizations proved IBM's teleportation hypothesis correct by successfully teleporting a photon, the particle of energy that carries light. The researchers at Caltech were able to read the photon's atomic structure, transmit that data over a distance of 3.28 feet, or approximately 1 meter, of coaxial cable, and then recreate the photon on the other end. Just as was foreseen, once the copy emerged, the original photon disappeared. The Caltech team had to get around something called the Heisenberg uncertainty principle in order to carry out the experiment. Any confined cat in a quantum state will confirm that it is impossible to know both the position and the speed of a particle at the same time, according to the uncertainty principle. Likewise, it is the primary impediment to the teleportation of anything heavier than a photon. Yet, how can one partake in such quantum teleportation if the location of a particle cannot be determined? Caltech's researchers were able to teleport a photon by using a phenomenon called entanglement, which does not violate the Heisenberg principle. In entanglement, you need at least 3 photons to achieve quantum teleportation. Photon A, the photon to be teleported. photon B, the transporting photon, and photon C, the photon that is entangled with photon B. Without entanglement, researchers may alter photon A by accidentally bumping it if they examined it too closely. Researchers can learn more about photon A by entangling photons B and C, with some of that information being extracted from B and passed on to C via entanglement. Researchers can make a carbon copy of photon A by using data from photon B to inform the design of photon C. Yet, photon A is not the same as it was before sending the data to photon C. When Captain Kirk travels to a distant planet, his atomic structure is analyzed in the transporter room and then transmitted to the destination, where a duplicate of Kirk is constructed. In the meantime, the original disappears. Teleporting living things is exceedingly complex, thus it has taken scientists since 1998 to go as far as moving a baboon through space. Their development is nonetheless remarkable. A laser beam was teleported in 2002 by scientists at the Australian National University, and in 2006, a group from Niels Bohr Institute in Denmark sent data from a transported laser beam to atoms located about 1.6 feet away. Team leader Dr. Eugene Polzik characterized the breakthrough as one step further because it was the first successful teleportation of light and matter, two distinct substances. A storage media is different from the information carrier. In 2012, scientists at China's University of Science and Technology set a new benchmark for teleportation. With this feat, they set a new world record by teleporting a photon 50.3 miles further than anyone before. Teleporting quantum information across a standard optical cable for use in telecommunications was only achieved 2 years later by European researchers. These developments demonstrate how quantum teleportation will impact quantum computing long before it speeds up your morning commute. These tests are crucial for the advancement of networks capable of disseminating quantum information at transmission speeds much faster than the fastest computers now available. Moving data from one location to another is the key to success, but will we as humans be able to take the quantum leap? Human teleportation. Unfortunately, transporters like those seen in Star Trek and The Fly are not only science fiction possibilities, but also possibly impossible in the real world. After all, according to Einstein's theory of special relativity, a transporter that allows a person to travel instantly to another location might also require that person's knowledge to go at the speed of light. Furthermore, the 1,028 atoms that make up a human body would have to be located and analyzed by the teleporter's computer before the person could be teleported. There are more than a trillion atoms in there. After gathering the necessary data, this miraculous machine would transmit it to a different place, where yet another miraculous machine would meticulously recreate the person's body. What would the margin for error be? If your molecules reassembled even a millimeter out of place after you spliced DNA with a housefly, you would arrive at your destination with serious neurological or physiological harm. Even the word arrive could be a bone of controversy. They wouldn't arrive anywhere the person was being transferred to. The whole thing would operate more like a fax machine, with a copy of the person emerging at the other end, though what would become of the original is unclear. When you send a fax, what do you do with the originals? Every successful biodigital teleportation would then be a combination of murder and creation. When you use it, your entire body is scanned and stored digitally, thereby creating a genetic clone of you replete with your personality, experiences, and aspirations. The original would have to be sacrificed whenever a copy is made for purposes such as cross-country travel or sending off young Jimmy to school, unless you view killing an infant as a form of sacrifice. Teleportation's fundamental ideas will undoubtedly be refined over time, as is the case with all technological advancement. Such a gloomy outlook on life, death, and teleportation may seem primitive and uneducated in the distant future. It's possible that our ancestors' eyes opened on a planet thousands of light years away while they were still feeling their bodies shrink and dematerialize on the home planet. Lots more information. One of those Frankenstein technologies, teleportation both frightens and intrigues us. It's hard to imagine a more desirable superpower than the ability to instantly transport oneself from New York to Bangkok or from Earth to Alpha Centauri. Technology at its periphery has the potential to radically alter what it means to be human and ensure the survival of the human race. If a machine can digitize your entire identity and recreate you on the other side of the world, why bother with an exact duplicate? How about an improved version that is a better representation of you in every way? If you can just hop in the teleporter whenever you feel old and out the other side feeling young, what's the use in worrying about aging? Biodigital teleportation both allures and terrifies us. This is why many science fiction depictions of the future feature unavoidable tragedy and inhuman terror. Because if we do, we will have conquered everything: matter, space, time, life, and death. There must be a wall separating humanity from such divinity, right? That pretty much wraps this video up, guys. Thanks for watching. What do you think about the phenomenon of teleportation? Share with us in the comments below. Make sure you subscribe to this channel with a bell notification if you enjoy watching our content. We upload some awesome stuff here which you will most certainly enjoy. Hit a like on this video and leave a comment below. See you guys in the next one.